All right, so we have isosceles triangle PQR. We know that QR is the base and PA is congruent to line segment PB. And we're trying to prove that AR, line segment AR, is equal to or congruent to line segment BQ. All right, Walter, you just had a really, really good idea. What was that idea you just said?
So I said outline triangle PBQ so you can see the separate sides.
PBQ. Okay, so you want to go with this one. Okay. And then are you gonna ask us to outline the other one too?
If you do it in a different color, I guess. But I only have pencils, so I'm only doing one.
Okay, so drawing these two shapes separately is a great idea because it makes it easier for us to see.
Oh, Jake's here.
Jake, how's it going?
He asked, is this a bad time to ask a question? That's what Jake said.
Yes, this would be a bad time to ask a question.
His office hours are not right now. This is geometry. He says, oh, okay. Oh, and he left.
Yeah, okay. So let's.
This is gonna be a good video, Mr. Frankie.
I know this is gonna be. This video is totally gonna go viral.
Viral.
All right, so we know this is P. This is P. We have B, A, and this point here is Q,
R.
and this one is R. Okay. All right, and so we know that this angle is congruent to this angle because they are
The same.
the same angle. All right, so we have our givens already written. Okay, so can I have a volunteer give us our first statement?
Okay, I will.
Okay.
PQ is congruent to PR because of definition of isosceles triangle.
Okay, so PQ is congruent to PR. Okay.
And then after that, you'd have angle P is congruent to angle P because of the reflexive property of congruence. Yeah. Yeah.
Okay.
And then it's because of SAS, the two triangles are congruent. Yeah.
Okay, so wait a second. In our drawing, we've proven that these two side lengths are congruent, that these two angles are congruent. What else is missing in our drawing?
Well, PB and PA, it's given that they're the same.
Oh, okay.
Yeah.
All right. So now we can say that triangle PEQ is congruent to triangle PAR. Okay. And you said, what did you say, SAS?
Yeah.
Okay.
And then because of that, your CPCTC, yeah, for AR is congruent to PQ.
All right. Great deal.
Yeah.
Okay. All right. So you said that we know that angle. Oh, that's the wrong thing. My pen switched. All right. So we know that angle 1 is congruent to angle 2. And we also
know that X is the midpoint of AC.
Okay. So X.
Wait. I think there's a theorem we're forgetting, and that's why we're having trouble. Yep.
Okay,
so
so these are our givens.
Yeah.
All right. And so we're trying to prove that X is the midpoint of DB, right?
Yeah.
All right, so, all right. So we're gonna do some strategy right here. All right, so what's our next step?
We said AX is congruent to CX because the definition of midpoint.
Yeah.
Okay. So AX and CX.
Angle AXD is congruent to angle BXC because of the linear angles theorem.
Not linear angles.
Vertical. Oh, my bad. That's what I meant to say.
Vertical angles, right? Okay. And so that is BXC. Okay.
And then we can say triangle AXD is congruent to triangle BXC because of the ASA that we use.
I think it's ASA.
Okay. It's typically it's you say the letters ASA instead of ASA. So just to make sure we got this right, we said AXD is congruent to, well, what side, what point corresponds with A? So it's C. So we have to go CXB, and that's triangle CXB. And that is by ASA, okay.
And so then we can, so after we say they're congruent, we can say EX is congruent to BX because of CPCTC. But after that, then we would have to say X is the midpoint because it's in the middle of two congruent segments.
And what was the, that's just a definition.
Definition of midpoint, yeah.
Yeah.
All right. That's it.
Yay.